Hello everyone and welcome to my latest Rust Quickie. In my previous Rust Quickie I have talked about so-called dangling references, and here you have learned that the Rust compiler just prevents them for you. Today we are talking about so-called lifetimes and lifetime annotations in Rust, and as you will see, the Rust compiler also uses lifetimes to prevent dangling references. So let's switch over to Visual Studio Code and let's have a look on all of these concepts. I have here a very simple function which demonstrates the concept of lifetimes. As you can see, I'm defining here a variable x, and inside another scope I'm defining a variable y with the value of 42. And as you can see, we are storing a reference to the variable y inside that scope. Means both variables x and y have different lifetimes. The variable x, as you can see, lives for the whole function, but the variable y just lives within that scope. And therefore, you can't store a reference to the variable y inside the variable x, because the variable y has a shorter lifetime as the variable x. And the Rust compiler sees that and generates you here a compile time error. So when we try to build that program with the cargo build command, we are again getting an error by the Rust compiler. The Rust compiler just tells us that the variable y doesn't live long enough, which makes sense, because we can't store a reference to that variable in the variable x. This wouldn't work. This would be again a dangling reference, because when we try to print out that value here through the reference, that value is already gone. And that's a dangling reference, and the Rust compiler just prevents that behavior for you. As you can see, the forward value does not live long enough. So this is very important here. So how can you prevent that problem? Well, the first very simple approach is that you make sure that the lifetimes of both variables are the same. So in our case, we just remove that scope from the variable y, and therefore the variable x and the variable y have the same lifetimes, and therefore we can store a reference to the variable y inside the variable x, and the Rust compiler doesn't give us an error message here. As you can see, when we try to compile that code now, everything just completes successfully, because the variable x has the same lifetime as the variable y. But that easy option doesn't always work. Imagine the following function, largest vector, not working. As you can see from the function signature, we have two input parameters, vector 1 and vector 2, and both input parameters are a reference to a vector. And as a result, we're also returning one of these two input references. As you can see, we are just checking if vector 1 has more entries than vector 2, then we're returning vector 1, otherwise we're returning vector 2. So that result is one of those input references, vector 1 or vector 2. So the Rust compiler has to know now the lifetime of the return value, but the lifetime of the return value can't be known during the compilation phase, because we have to run that program to find out which vector is the largest vector, vector 1 or vector 2, and therefore the Rust compiler can't determine the lifetime of the return value. So when we try to build now that code, we are getting an error message from the Rust compiler. As you can see, when we scroll up, we have that error message that we have already seen in my previous Rust Quickie about dangling references, missing lifetime specifiers. So the Rust compiler just tells you that it has no idea what the lifetime of the returned value is, because the lifetime of the returned value depends if we are returning vector 1 or the reference to vector 2. As you can see, when we are going down, the Rust compiler tells us now that we should consider to introduce so-called lifetime parameters, lifetime annotations. So let's have a look on them. So what is now a lifetime annotation in Rust? A lifetime is introduced with the apostrophe sign, and it's just spelled out dick, like dick A is a lifetime annotation. So in our case, we are telling that vector 1 has a lifetime of dick A, and vector 2 also has a lifetime of dick A, means they both having the same lifetime, and therefore the returned reference to the vector has also a lifetime of dick A. And in addition, you also need to specify that lifetime annotation dick A before the input parameters in the function signature. So now, with those annotations, the Rust compiler just knows that vector 1 and vector 2 have the same lifetime, and therefore the Rust compiler can also know the lifetime of the returned reference. So more or less we are just helping here the Rust compiler. It's just somehow synthetical sugar. So when we now try to build that command, to build that program with the cargo build command, you can see now that we don't have any error message anymore, because the Rust compiler knows now the lifetime of the returned reference. Let's try now to use that function largest vector working, where we have introduced lifetime annotations. As you can see, I have here another function, and within that function I'm defining a new vector which just stores some string values, and within a new scope I'm defining a second vector with some other string values, and within that scope I'm calling that function largest vector working, and we pass in references to both vectors. As you can already see from the code, both vectors have different lifetimes. Databases 2 has a shorter lifetime as the vector databases 1, but we return one of those two vectors as a result. Means when we afterwards want to print out that result, it could be databases 2, which is already out of scope. That vector also allocated some heap memory, and that heap memory is deallocated as soon as that variable leaves that scope. So in that case we would access here again a dangling reference, and therefore when we try to build that program now, we again have errors. The Rust compiler just tells us that databases 2 does not live long enough. Previously we have annotated that function largest vector working with lifetimes, and now with that additional information the Rust compiler just tells us that this doesn't work, because that variable, that reference databases 2 that we pass in, does not live long enough. So that code just doesn't compile. So the Rust compiler again prevents a dangling reference here. When we now rewrite that function so that both vectors are having the same lifetime, then we can call that function without a problem, because the Rust compiler just knows, based on the lifetime annotations that we have done, that databases 1 and databases 2 have the same lifetime. As you can see, I have removed here the scope for databases 2, and therefore the vector databases 1 and the vector databases 2 have the same lifetime. Therefore we can call that function, and afterwards we can access the reference which is returned by that function. So as you can see, when we build now that program again, you can see that everything has just compiled successfully. But we have to work here with lifetime annotations so that the Rust compiler just knows how long those references are living, how long they are just alive. Without that information, the Rust compiler could not compile that program for you. So this is very, very important here. I hope that you have enjoyed today's Rust Quickie, where I have introduced lifetimes and lifetime annotations to you. In my next Rust Quickie, I will talk about a completely different topic in Rust, and I want to cover here so-called structs. So thanks for watching, and I'm already looking forward to see you next week again. Thank you.